Engineering Department, Parul Institute of Technology, arrange a webinar on an era of electrical vehicle. I would like to welcome Mr. Naveen Shah, sir. Right now, he has a vast experience in a teaching, that is the 18 years of experience, and he is holding post-graduation in power electronics, and right now he is pursuing his PhD in the interest of multi-level converter, modulation, and electrical drives from MS University. I would like to welcome Sunil sir. Please give your uh, webinar on an era of electrical vehicles.
Thank you, Jackson. Thank you. Am I audible to all? Is it clear to all?
Yes, sir.
Okay, okay, fine. So let me share my screen, and with that, I would like to start the webinar. So, is it visible? My screen is visible?
Yes, sir.
Okay, fine. So, good morning, one and all. Today we are here to discuss something about era of electric vehicle particularly, and the title here given is era of electric vehicle. So let us first of all discuss what is the various eras of vehicle, and why now it is era of electric vehicle. So if we look at the history of vehicular technology, it started somewhere around 17th century, 18th century, somewhere around 1770. A steam engine was formed, and initially the vehicles were running on steam engine. These vehicles were running for almost 1.5 century. Between this time, researches were going on IC engine, gas-based engine, and petrol-based engine and all. And it was a year of 1893 where first petrol-powered vehicle was developed. Meanwhile, there were attempts to make electric vehicles in the beginning of 20th century, somewhere around 1901. The first 1901 first electric car was made, and from 1901 to 1920, many attempts were made to make electric cars. But then, at that time, it was favorable to have gasoline engines, means petrol and diesel engines. And 1924 onwards, the vehicular technology was mostly uh, concentrated about this IC engine based technology and all. And almost for a century, it has led the world. But now, let's look at how electric vehicle has changed or is changing fastly. And already we can say that there is a down of electric vehicle. Already sun has raised. Now we can say that IC engine technology is in full blossom, but now it is towards we can say uh, the downfall of this technology is started, and why? Let us try to see. To begin with, we will see the numbers. Okay. Now, before that, what is electric vehicle? So simply we can say that a vehicle which is driven by electric motor can be said electric vehicle. There are three different types of electric vehicles. We can say battery electric vehicles, plug-in hybrid electric vehicles, and hybrid electric vehicles. Now, when electric vehicle technology was started, somewhere around 1990, electric vehicles were started. And soon it was realized that this electric vehicle technology has been carried forward with the hybrid electric vehicles. So first of all, hybrid electric vehicles were in became popular. Then plug-in hybrid electric vehicles came, and lastly, lately, battery-operated electric vehicles are becoming more popular now. So, in case of hybrid electric vehicles, what actually happens is, uh, in case of hybrid and plug-in hybrid electric vehicles, there has been IC engine also along with electric motor as a propulsion system. And in case of hybrid electric vehicles, IC engine is connected with generator, and this generator will charge the battery, and through battery, motor will get the power. Whereas in case of plug-in hybrid electric vehicles, you can have external source of electricity which can be connected for charging batteries along with IC engine also. Whereas in case of battery electric vehicles, there is no IC engine, there is only battery and electric motor. Okay, so these three are the popular electric vehicles. So now onwards, whatever discussion will be there will be in terms of battery electric vehicles as well as hybrid electric vehicles. Okay, so now let us check the numbers. This graph has been obtained from IEA, that is International Energy Agency. They have prepared this excellent outlook, which is comprising data of 2010 to 2019 regarding electric vehicles. And if we look at it, we can realize that China, Europe, and US, these three regions are leaders in electric vehicle. As far as China, Europe, and US are concerned, they have 33%, about 33% population of the world, but 90% of electric vehicles are concentrated in these three regions. Secondly, if we look at this graph carefully, other thing which comes, which is very apparent is uh, battery electric vehicles are fast growing as compared to hybrid electric vehicles. So it clearly indicates that battery electric vehicles are technology of very recent future now, and entire world has been moving towards these battery electric vehicles. Electric bus, perhaps if you have carefully observed some news, Calcutta is the city where electric buses are there in their for their local commutation. Not only that, if we go to the airports, Indigo Airlines is there, which is carrying passengers from airport terminal to the plane with their buses, and they are also electric buses. So in India also, electric buses are becoming popular, and significantly we can see that in 2018 and 19 there is adoption of electric vehicles. But again, if we look at other countries, China is large outnumbering rest of the world with the numbers in hundreds of thousands of buses they have already placed, electric buses they have already placed. And Europe, in Europe also, electric buses are penetrating more. Rest of the countries are still lagging in these electric bus registrations, means adoption of electric buses. And if we look at electric trucks, again, if we see at the numbers, see in 2010, there were very small amount of electric buses. And as the number of years are passing, significant figures are observed, particularly in 2019. And again, we can see that more than 6,000 trucks, electric trucks, are registered in China in 2019. So again, as far as electric trucks, adoption of electric trucks is concerned, China is leading the world. This year, due to COVID-19, there has been a large fall in the sales of automobiles. Almost 28% fall in automobile sales has been observed in first half of the 2020. But if we look at electric vehicles, the numbers are mixed. Global electric vehicle sale has fallen by just 14% as compared to total fall of 28%. And if we observe significant numbers, Europe and China have two significant trends. In Europe, there has been larger adoption of electric vehicles even in COVID situation, and in China, there has been fall in electric vehicle sales. The reason behind fall in electrical vehicle sales in China is not COVID. There is other reason which we are going to discuss in a short while. This data has been taken from EV volumes. So again, one more data. See, global EV sales ranking, and if we try to see the names, the first and foremost name come in this list is Tesla Incorporation. That is US based company. They are selling their electric vehicles in very large number. And again, if we see this trend, see battery electric vehicles are quite outnumbering plug-in hybrid electric vehicles. Okay, so hybrid electric vehicles is of least choice nowadays for customers, and battery electric vehicles are outnumbering them. Okay, so what we tried is we tried to see the trend of sales of electric vehicles over the world in past decade or so, and there is clearly visible trend of electric vehicle sales. Okay, with this all, in 2019, the total number of electrical vehicles sold in entire world were just 2.6% of electric vehicles sold in entire world. Okay, and it is expected that by the end of 2020, the total electric vehicle sales will be somewhere around 3.5%. So this trend is rising. This trend is rising. Sales of electric vehicle trend is rising. World over, in 2017, a resolution was passed that by 2030, there has to be 30% electric vehicles. So why there is shift from IC engine to electric vehicle? This trend shows us that there is a visible shift of choice from IC engine based vehicles to battery operated vehicles. So what are the reasons? Let us try to have those reasons. Here, this first photograph this first photograph actually indicates Pradyuman Park of Rajkot. If few of you may have visited it, it is a big zoo, and to move in the zoo in vehicle, this is the battery operated car which carries people in that zoo. The second, this excuse me for a while. Okay. This second picture is of sea near Florida, and there is a yacht which is solar powered yacht. And one more figure is the third is of some tourist place where a motorboat is there which is powered by electric motor. Okay, so the reasons behind adoption of electric vehicle is the technology is cleaner. There has been zero emissions of hazardous CO2 and methane gases, or very less amount of emissions. Secondly, it reduces noise pollution also, and that is why many tourist places at many tourist places electric vehicles are preferred. Okay, so it is cleaner, it is greener, obviously, it is leaner. Now, why leaner? So vehicle and battery cost are rapidly decreasing. Also, the maintenance cost is decreasing because there are lesser parts in it and lesser wear and tear. So these are the reasons why people try to adopt electric vehicles. But then the road ahead is not so smooth. There are a lot of challenges in adoption of electric vehicles, and those challenges needs to be tackled with. First and foremost challenge is range anxiety. See, at this point of time, if we have a four wheeler, which is means IC engine based four wheeler, then it will have a fuel tank of around 40 liters. And because of that, once it is filled completely, we can easily ride for 400 to 600 kilometers without refueling it, based on the type of vehicle and its average. Okay, and then too, if at all we feel that it is refueled, we can easily locate the fuel pump. We can refill it in a very short while, say 10 minutes or so. We can refuel our tank and we can go ahead. So we are accustomed with these all. And now, if we try to adopt electric vehicle, questions arise are: do we have enough charging stations in between, or does our vehicle have enough of range? Suppose a person tries to travel with electric vehicle from Ahmedabad to say Bombay. It is around 500 kilometers or so. So once he has got fully charged batteries, and if he starts traveling with that vehicle, is it possible to reach Bombay without recharging? No. At this point of time in India, whatever electric vehicles are there, they do not have that range. Secondly, if at all he wants to refuel in between, do we have charging station? Again, the answer is big no. So these are the things which are hindering adoption of electric vehicles. Second is battery life and its sustainability. How long batteries will last? Now, uh, for that, what actually is done? Suppose somebody buys a car, around 37% of its cost is due to batteries. Electric car cost more, and 37%, 35 to 40% cost is of batteries. So if after 3 years, suppose it will really be a costly affair, and people will get annoyed with electric car and they will not adopt it also. What present day manufacturers has done, we will see later on also, and can discuss just now that Tata Nexon EV is electric car. What they have done is they have come up with a battery warranty of 8 years period. Means within 8 years, if your batteries are getting damaged or not working properly, they are ready to replace. Okay, so they have come up with a battery warranty of 8 years. Other question may be what to do with these batteries after their useful life. Okay, so dumping of used batteries can be again an issue as far as sustainability is concerned. How will it affect environment? Those studies are not done properly, or they are undergoing with those studies means, and the effect on environment is still unknown to the world. Another challenge is upfront cost. Though running cost of the vehicle, electric vehicle is lower, at the beginning when we buy the vehicle, at that time the cost of vehicle is high enough. Tata Nexon EV, if we are talking, its base petrol model is somewhere around 9 lakhs, whereas its EV model is somewhere around 14.5 lakhs. So upfront cost is again very high. With these, companies are coming up with different business models. Again, I am taking example of Tata because it is there in India. That is why I am taking that example. What they have done is they are giving these EVs on rent. They have come up with 18-month, 24-month, 36-month rent period with different rent rates. And the rent rates are so decided that if a person is taking a vehicle on rent, then within 3 years, company is able to cover the entire cost of vehicle, and at the same time, customer then has to pay just rent and have to bear charging cost only, nothing else. Okay. One more question may arise is whether electric vehicle is safe or not. Will there be any accident? Will there be what if vehicle is used in rainy season or so? Okay. So these are the challenges, and they need to be addressed. Now, uh, as far as electric vehicle is concerned, it is, even though it is replacing many of the mechanical parts, then too it is not a very simple system. It is a complex system. See, this bottom block is of energy source, that is battery source. So there has been one system of battery. There is one system of propulsion, and there is another subsystem which is running auxiliary requirements. These auxiliary requirements are low voltage, low power requirements, like there can be motors operating for side glasses or window glasses also. There can be motors attached with the compressor for cooling, like that. Okay, so these are the auxiliary systems which run on low voltage, low power requirement. Here is electric motor, which will have other requirement than what auxiliary requirements are there. Both are to be sourced from the battery, and excuse me, both are to be sourced from the battery, and battery will not feed directly to the motor. There is in between motor and battery there will be electronic power converter. What will it do is it will convert fixed DC voltage of battery into the voltage profile required by electric motor. This electric motor can be AC motor or DC motor. So accordingly, whatever modification in voltage profile is required, that can be done with electronic power converter. And this electronic power converter, which will actually have inputs from the driver, whether to be motor to be accelerated or whether to be stopped or whatever signals are to be given, that has been given by the driver, and accordingly the voltage profile of the given to the motor will be modified and control of the motor is this is how control of the motor will be done. So this diagram actually indicates the various subsystems of the electric vehicle, and looking at this block diagram we can realize that there can be many controllers used for management of subsystems. Now if we look at different powertrains, then there can be hybrid electric vehicle or battery operated electric vehicle. If it is battery operated electric vehicle, then there is a direct motor is directly driven from battery, and then output of motor is given to the wheels with mechanical transmission system, and that is how battery operated electric vehicle will run. Okay, but if there is hybrid electric vehicle, then there will be IC engine will also be there along with motor and generator, and there are two possibilities of connecting these IC engine with motor. They may be connected in series. If they are connected in series, then what happens is electric motor will only drive the will be the prime mover for this mechanical transmission of the vehicle, and battery is charged with the generator which is run by IC engine of the motor, and the output of generator is given directly to the battery. There can be other mode also called parallel hybrid powertrain, wherein motor as well as IC engine both will drive the transmission system, and series parallel means motor will drive mechanical transmission sorry, IC engine will drive mechanical transmission as well as electric motor also. So these are different powertrain mechanisms of electric vehicle. And if we look at battery operated electric vehicle have simpler powertrain as compared to hybrid. Now, how these various drivetrain systems are attached. So, how motor is attached to the wheel. That is what we can simply realize. In first case, there is a mechanical transmission system attached with motor, and then there is differential gear, and then the output is given to the wheel. Then in second case, here there has been no transmission mechanism. Motors can be connected in cascade, and then there can be drive mechanism is observed with cascaded motor, without gear or with gear. In wheel direct drive system means motors are separately connected to each wheel and they are separately controlled. This is how different drivetrain mechanism systems are there. Now, different motors. So if we try to classify electric motors, we can broadly classify electric motors in DC motor and AC motor. As far as DC motors are concerned, in 90s, DC motors were used in the electric vehicles. Now they are seldom used. Another DC motor used is BLDC motor, BLDC motor. These BLDC motors are of two types. BLDC means brushless DC motor. So there is no brush mechanism, so there will not be any wear and tear of brushes and all. These BLDC motors are of two types: permanent magnet BLDC motors. So instead of having field winding, the field is generated with permanent magnet. Field will be available with permanent magnet system. And another type is coreless DC motor. Coreless DC motors are really very tiny motors, and those coreless DC motors are of the size of, say, capsules, like that. Very tiny motors are there. You may have observed them with the drones. Those toy drones are there, or drones are there. Kind of motor used there is coreless BLDC motor. Okay, wherein there is no core, just a winding is there. So these are the DC motors. As far as AC motors are concerned, AC motors were used where initially induction motor were used. Nowadays, because of development in motor technology, permanent magnet synchronous motors and switch reluctance motors have gained more popularity, and they are vastly used. Latest model of Tesla car, which is highest selling model of the world, have switch reluctance motor SRM. This switch reluctance motor has its own distinct advantages. It requires, actually, it does not require any external ventilation system, as these stator and rotor slots are projected ones. So there will be natural circulation of air, and because of that, better airflow is maintained and cooling will be easier for these motors. It has special kind of rotor, and this rotor does not have winding. Okay, it is just a ferromagnetic material used in making this rotor, and therefore there is no need to have any brush and slip ring assembly along with rotor. It will be light as well as maintenance free. They do not comprise any permanent magnets, and hence they are cheaper. As far as their control is concerned, for that we may require pulses only. Either two-phase or three-phase pulses can be given, and those pulses the motor can be controlled. If the direction of motor is needed to be reversed, obviously needed to be reversed. If it is a four-wheel drive, we need to reverse our vehicle. In that case, only thing to be done is phase sequence is to be altered. Suppose it is a three-phase system, then if phase is, say, present phase is ABC, phase sequence is ABC or RYB, with that forward movement of motor is observed, then to reverse the motor, we need to change this phase sequence as RBY, and motor will be driven in the reverse direction. Okay, so by just changing the phase sequence, we can reverse the direction of motor. It is self-starting kind of motor that do not require any other arrangement for starting, like some capacitors or any other additional starters are not needed. Its starting torque is very high, which is very much essential. And that too without excessive inrush current, which is the case in case of induction motor. The starting inrush current is around 7 times of its full load current, whereas here SRM will have 1 to 2 times its full load current only at the time of starting. So starting inrush is not an big issue for SRM, switch reluctance motor. It has high fault tolerance, means less maintenance, Okay. One more feature which makes it more popular is it has high torque to inertia ratio, or we can say high torque to weight ratio. For its weight, it offers the maximum torque among the class of different motors. And that is why it has gained popularity and it is vastly used in vehicular technology. So, this is about motors used for electric vehicles. Now, if we look at the characteristics of electric vehicle, it slightly motor requirement or characteristic requirement for electric vehicle is slightly differing as compared to the other purposes of electric motor or say industrial purpose of electric motor. What is the difference is the torque requirement. Torque requirement means overload torque required may be somewhere around 4 to 5 times rated torque situation. See, sometimes vehicle has to raise the through gradient, or some terrains are there which are challenging for gradient, means challenging for vehicles. At that time, we require higher torque, and motor should be able to provide that torque. Otherwise, vehicle will be not be able to climb those steep rises or like that. So at that time, torque requirement is quite high, which is generally does not observed, which is not observed with typical performances in industry. Not only that, the speed, if we think again, speed is quite high as compared to base speed. Base speed may be means as compared to base speed, the maximum speed requirement may be 4 to 5 times for cruising. Okay, for fast moving and all, we require higher speed, which is not generally the case with industrial requirements. So these are the typical requirements which are not observed in other purposes, and that is why those typical requirements are to be mitigated with the motor associated with electric vehicle. Now this is a block diagram which is indicating interfacing of electric vehicle with battery and other systems. So here this vertical line, this vertical line indicates a DC bus, and the energy on this DC bus is from energy storage, that is from battery, through DC to DC converter comes on this DC link. Now this DC link will be given to motor drive, that is a power electronic converter system, and after the output of converter will be given to the motor. Now there are two possibilities of the motor. Motor can be AC motor or DC motor. If the motor is say DC motor, then it is very likely that the rating voltage rating of the motor is different as compared to the battery pack offering the voltage. Okay, and in that case you require a converter which actually raises the voltage level or reduces the voltage level for different purposes. Okay, so the DC to DC converter needed to drive the motor has to have both options with it. It should boost the voltage if required. It should reduce the voltage if required. So this DC to DC converter here will be a buck boost converter. It is called buck boost converter. Just like it behaves like a variable variac we can say, but variac varies the AC voltage. Here this converter will vary the DC voltage as per the requirement. Okay. Now when we are operating this motor, this drive with the motor, there are possibilities that while applying braking, whatever energy is to be lost can be regenerated and fed back to the energy storage system. Okay, so while braking earlier, the kinetic energy of the vehicle was lost in heat and all. Okay, but if we adopt electric vehicle, then while braking, this energy can be fed back to the energy storage system. Okay, so there has been path has been given. See, this green path actually offers discharging condition wherein path of energy flow is from energy storage system to DC link bus to motor. Okay, whereas when we apply braking, at that time reverse path of energy flow is observed from motor to energy storage through this DC link bus. Okay, now if this motor is AC motor, then the converter system needed here needs to be inverter. What inverter does is it converts fixed or whatever input DC voltage is there, it is converting it into variable AC output. Okay, so variable voltage AC output is observed by this converter system, and output of that converter will be given to the motor. Now, this converter is dedicated for driving the motor. Here there has been another converter which is DC to DC converter which is dedicated for energy management of the energy storage system. What this converter will, how this converter will operate? As far as these two converters are concerned, they can be treated as if it is the heart of the system. It pumps the energy in either direction. So that way we can consider it as if it is the heart. Then how this heart should pump, that is decided by the control mechanism. This control mechanism is actually implemented with the help of different types of controllers like a microcontroller or say a DSP, digital signal processing device, or we can have a FPGA kit. Likewise, different control mechanisms means control is implemented with the help of different platforms, either microcontroller or DSP, or we can say FPGA board. Okay, so those controller will actually be the brain of the drive, brain of this electric vehicle. So is very important. Actually, this will actually decide the performance of electric vehicle. Again, on other side, see, one more converter is observed, and that is with the external charging mechanism. A utility plug is there. We can have a plug and play arrangement with which we can have charging of our battery. So one more converter is there, and that is external to the vehicle. Most of the time it will be external uh, to the vehicle uh, with the charging arrangement. Okay, the input to this converter will always be AC, and battery has DC voltage. So AC to DC converter will be there, and this conversion is called rectification. So it is a rectifying converter system which will go for which will work for energy storage, right? So if we look at this block diagram and try to understand what electric vehicle is, it suggests that there are ample opportunities in the field of automobiles for electrical engineers, for electronics and communication engineers, for IC engineers, and all, for mechatronics engineers, for robotics engineers, for all. There has been ample opportunity in the field of electric vehicle. You can work for it. There are ample problems to work on, and it offers the immense opportunity to us. See, again, if we look at global data, the today's manufacturing operations globally can produce 320 gigawatt hours of battery per year for use of electric cars. See, in 2019, the amount of electric cars, number of electric cars sold were of 2.1 million. Okay, and for that, 100 gigawatt hour batteries are sufficient. But then, at present, it is 320 gigawatt hour battery production capacity of the world. As of now, it is ample. But by 2025, it is assumed that 1000 gigawatt hour battery capacity is required because now it is on the growth path. Various countries, particularly Europe, has taken lead. Many of the European countries have, if we look at the sales of electric vehicles in European countries, in many of the European countries, in fact, it is very significant, ranging from say more than 10% to say about 50-60% of vehicles sold last year were electric vehicles, right? So they are significant number. It is the significant number. If we look at China, they are the world leader in the number of electric vehicles, but it's a vast country and number of vehicles sold is very high. So percentage wise, it will be small, but number wise, it is a huge number. And this is the present day data, present day situation is for 33% of world only. We can say because it is concentrated in three regions: Europe, US, means North America, Europe, and China. Rest of the world has just initiated adoption of electric vehicles. As far as battery is concerned, previously, to begin with, lead acid batteries were used in automobiles. Till today, it is used, but in present day automobiles with IC engines, these lead acid batteries are used for auxiliaries like lighting and other purposes. Whereas if we try to use them, means lead acid batteries as a main source for driving the electric motor propulsion system for electric vehicle, then it will be very bulky. The weight will outnumber significantly the other, means petrol tank and fully filled petrol tank and all. So the shape and size of electric vehicle will not be of what present day vehicles are. So there has to be another option as far as battery is concerned. And since 1990s, it is the lithium ion battery which is Now, in a 30 years, it is on the verge of spreading, means the cells of these lithium ion batteries is quite large as compared to these lead acid batteries. And for vehicular technology, whatever batteries are used for driving electric motor are of lithium ion type. The reason is lithium is the lightest metal of the earth, and that is why lithium technology based batteries are gaining popularity because of low weight and high power density. For a given size, it will be able to store and deliver more amount of power as compared to any other battery mechanism. That is why lithium ion batteries are vastly used. These present day lithium ion batteries again has some concerns as far as their operations are concerned. One most thing is the charging cycles, number of allowable charging cycles. What do we want is our battery should have more number of charging cycles as far as possible. The reason is if it is so, then it is means the frequency at which it is required to be replaced is less. The reason is, see, suppose a vehicle is there with a battery having 300 charging cycle capacity, and another vehicle is there which has 1000 charging cycle capacity, means battery will be healthy, will give healthy performance for 1000 charging cycles. Then if we consider that daily our batteries of vehicle are needed to be charged, then in first case we need to replace the battery just after a year of operation. In second case, roughly we can say we need to change the battery after 3 years. Okay, so that way, and since has battery is the most costly component of the entire vehicle system, and that is why frequent replacement is not affordable and not advisable, and that is why a lot of research is going on. If we are able to reduce the size of the battery for same power density, then two things may happen. Either the weight of the vehicle will be reduced, or otherwise we can accommodate more number of batteries, and by accommodating more batteries we can increase the range of the vehicle. Okay. See, patent data was observed, and trends in electric storage innovation, if we look at total IPFs fine, means international patent filings from 2000 to 2018 have increased by 213%, whereas electricity storage related IPFs are increased by 704%. What does it mean? That researchers over the world are putting lot of effort in modifying these electric storage system. Okay. Again, if we look at the number of patents held by any country related to electric storage innovation, then that credit goes to Japan. Lot of innovations are going in Japan, and Japan is the world leader as far as patents of number of patents are held by held. Okay, but if we look at the number of fast chargers installed over the world, China is outnumbering the entire world. Okay, we'll see that. See, this is regarding number of patents filed for battery cells. If we look at the most number of patents for related to batteries are filed in this lithium and lithium ion based battery technology. Okay, this dot is becoming bigger and bigger as the years are progressing. Other chemistries are lagging five, means people are working for alternate chemistry also, right? And based on that, number of patents means if we look at the number of patents filed, we can realize the scope of innovation in the battery technology. And
Hello,
people,
sir. Your voice is breaking. Sunil sir.
okay, uh,
Hello, Sunil sir.
is it? Yes, sir. Yes. Now
Hello.
is it okay now? Is it okay now? Hello.
Yes, yes, sir. Is it okay now?
Okay, fine. So it is the lithium ion battery which is gaining lot of attention of research community. As far as this research is concerned, chemical engineers, metallurgists, electrical engineers, all may be involved in the research of these batteries. So, not exclusive domain of any electrical engineer only. Other engineers can also involve themselves for battery cells technology. Okay. Now, one of the reason why adoption of electric vehicle is not so fast is the charging infrastructure. But then too, public charging points, number of charging points world over has reached a significant landmark of 1 million in May 2020. Of course, China is at distinct first place with Europe and North America at second and third positions respectively. This is the world over charging facilities availability. See, there are three different types of chargers: slow, medium, and fast. If slow charger is there, then its wattage kW capacity for charging is lower, and it will require around 2.5 days to fully charge the battery. If medium fast means medium chargers are there, then we can say that we are talking in terms of speed of charging. Then it will take around say 9 to 10 hours to say 90% for 90% charging of battery. And fast chargers are taking somewhere around 1 to 2 hours for charging the battery. Again, if we look at these data of fast chargers, the most significant number is, see, total number of fast chargers are 2,64,000. Tesla company has installed more than 17,000 fast chargers in US. Okay, but again, China is outnumbering any other country with 81% of world over fast chargers located in China. Okay, so we can say that vehicle technology has been maturing in China, and that is why gaining lot of popularity and lot of adaptation. Not just that, it is because of government spending and trust offered. In fact, see, when solar energy was new, at that time, lot of subsidies were offered by government, and till date it is offered. Okay, at our place also, if we want to have rooftop solar power plant, government offers subsidy. Same way, for adaptation of electric vehicles, again government provides subsidy. China was offering large subsidy on these electric vehicles from say around 2015. They have increased that subsidy, and in last 4 5 years, there has been larger adaptation of these all electric vehicles in China. This year they have reduced the subsidy, and that is why the reason is there is fall in electric vehicle sales in China. Okay, it is not COVID due to which there is fall in electric vehicle sales in China. We have seen that 42% fall was observed this year in first half of in first half for electric vehicle sales, but it is due to reduction in subsidy on electric vehicles by Chinese government. So we have been looking scenario of the world till now as far as these electric vehicles has been concerned. Now let us look at the Indian scenario. What is the case in India? So India's first public EV charging plaza has been shown here. Picture of first EV charging plaza, which is just inaugurated in on 20th of July at Chelmsford Club in New Delhi. Right, and in that also they are of different capacities. So few are fast chargers and others are medium fast chargers. Okay, slow chargers are the chargers means normally the automobile companies are giving chargers with electric vehicle and they are medium capacity chargers, so they will require around 5 say 9 hours or so to fully charge your electric vehicle, particularly a four wheeler. I am not talking about two wheeler, I am talking about four wheeler. Now Indian government has recently introduced FAME 2 policy. FAME is faster adaptation of manufacturing electric vehicles, and it is between 2000 means from 2019 to 2022, and against the trend of other countries wherein adoption of electric vehicle is good, they are reducing subsidies there, but here now the Indian government has been increasing the subsidy. Okay, now demand incentives means those who are buying vehicles, for them government has kept hefty amount 8,596 crores to be spent in 3 years. For charging infrastructure it is 1,000 crore. Okay, and where these chargers are to be located first. For that, in first 3 years, means 2019-20 to 2021-22, they have identified 9 cities of India which had population over 40 lakh in the 2011 census. In those 9 cities, they are actually developing these facilities of chargers. Apart from that, in more means in uh, 5 years, India is to develop more chargers on highways, particularly on expressways. So 9 cities and expressways are the initial phases on which government will spend lot of money to develop the charging infrastructure. So it is of just near future, and we will see that lot of charging infrastructure will be developed in and around us, because as we are located near Vadodara, which is on the way of express highway Ahmedabad Vadodara, and which is to be extended up to Mumbai. So we will see a lot of charging infrastructure around us. Okay. Recently, Gujarat government has also announced uh, policy for means incentives for electric vehicle adoption. Those who are college students or say up 11th onwards, those who are as a, well, studying, those who are the students, for them there is policy that when they buy two wheeler, government is providing subsidy of 12,000, and if three wheeler are bought, then the amount of subsidy offered by the government is 48,000 as far as Gujarat is concerned. Okay, so in India, these subsidies are there for supporting, but what is the actually the range and model availability of these electric vehicles? Let us try to see. For that, I am directly I am directing you to the site of government. This is Department of Heavy Industries site. and see different manufacturers with their models and incentive amounts are given. Let us take Tata Motors and its latest four-wheeler Tata Nexon. Incentive amount fixed is 2,99,800. And let us have detail of these model. See, it has a range of 312 kilometers. So it is the declared range by the manufacturer. So we can expect that it is somewhere around 250 kilometer only, right? As far as battery capacity is concerned, it is 30.2 kilowatt hour, right? And number of battery cycles are 1200. What Tata has done is they are offering 8 years warranty and that rent rent model and all to popularize these electric vehicles. There are other manufacturers also. Let us have a look at two-wheelers. Then these Ampere, Okinawa, these are the two-wheeler manufacturers. One of the model of the Ampere, if we look at, this is the model and battery capacity, range and number of cycles are given. So that way, if you want to buy any electric vehicle, you can go for these basic technical specification on this national site, and you can realize and have comparison between vehicles. And to end with my presentation, some of the interesting innovations in electric vehicle technology, if we look at, one was Solar Impulse 1, made in 2009 and run on solar energy only, and had made a record at that time around 36 hours of flying with single seater, means single seater person, means only one seater plane. So this is also innovative arena in electric vehicle. Another is drones. We cannot exclude drones now in vehicle technology. And solar drone was developed in NUS Singapore, National University of Singapore. There, this drone was developed in 2018. Now, if we know that drones have limited capacity of flying of a few minutes to say a few hours only, uh, but for weather forecasting and other requirements, if we can have a drone which can continuously fly for days and months and years, then it can be of excellent use. And with this aim in mind, this solar drone is developed in Singapore, University of Singapore. One initiative was taken by Indian Railways wherein they have installed solar panels on trains which are generating electricity and readily used by these trains. So these are some of the interesting innovations in electric vehicle. This is all about today's presentation. I hope you have enjoyed it. Am I audible?
Yes, sir. Thank you for your time and your knowledge. We get very much, we get different angle of the electrical vehicle from your webinar. Thanks for your time, sir. Thank you.
Okay, okay. Okay. Thank you,
Okay, sir.
Jackson. Thank you.
Thank you.